NPA in the last year, got, right away just got active with us on our Saturday morning conferences. Two or three presentations already, and he's going to give you two presentations this morning. The first one on the God particle, and the second on the God computer. So, Franklin, who?
Thank you very much. I mean, it's terrific to be here. I flew in from Seattle to get here. And boy, my arms are tired. But I want to tell you just a little bit about who I am. I started with the NPA maybe 8 months ago, and I heard about them because of Margaret Wortham's book, Physics on the Fringe. And there was someone who actually visited James Carter and gave a speech, and this is how I found out about the NPA, and my life has never been the same ever since. So, but I started this out maybe 10 years ago, 203, and I was in like a pretty bad car accident. I got T-boned. I did walk away, but I think there's nothing quite like almost getting killed, but your life into perspective. And I suppose one of the things I did is I started my new science hobby, which I always had an intense interest in science. But so I started off in this whole thing. I think I first started out on atoms and stuff. So in the proceedings, starting on page 119, I have 4 papers, and today I intend to present on 2 of them. And I might get to the other ones later if we have extra time. But like Greg said, are you guys all familiar with the Saturday NPA conference? Every Saturday at 7:30 a.m. Pacific time and like 10:30 Eastern time. Everyone from the world in the NPA, they call together into a video conference. And you can find this video conference on the worldnpa.org website. You just go look at upcoming video conferences, and people like yourselves, you don't have to wait a whole year to be involved in these kinds of lectures. It happens every week. And so you just contact Greg if you want to speak. They'll stick you on the calendar, and all you need is a reasonably powerful personal computer, a camera, and most importantly, you need headphones, because otherwise you get a terrible echo if you try and participate in our video conferences without a headphone. But in any case, you'll find me at those weekly conferences. I attend nearly every one, and I'm always asking questions. And I have already given 3 presentations. So for the two papers I'm not presenting on, which is the cubic atomic model and is gravity the electrostatic force, you can actually find the 2-hour NPA conference on the NPA website, along with dozens and dozens of other presentations that you might be interested in. So if you didn't get enough here at the NPA conference this year, well, there is just an infinite amount of other lectures from other people that you can have a look at. Okay, so I encourage you to check that out. I want to see all of you at the next the Saturday conference. There is also another smaller group that participates from Glenn Baxter. He has a world shortwave program, and he gets together a small group of people to discuss things on his talk show and also through email. But I warn you, if you get on his email list, you'll be spammed with like 10, 15 messages a day, and you'll be very busy deleting messages out of your email box. So just a little warning about that. Okay. So my goal here when I try to explain something is that I'm trying to explain things in a way that ordinary lay people will understand. For example, on the way to the on my way here, I was explaining my theories to the guy who was just sitting next to me, right? And my goal is to come up with theories that people would actually have a chance of understanding. Now, that doesn't necessarily mean that you agree with it, but it is expressed in such a way that we only related to things that that people can understand and relate to. Okay, and so that is what I'm going to try and do. I'm going to try and give you answers to complicated subjects like what is mass, what is inertia, what's gravity, how do magnets work, you know, in a way that you could go in your next dinner conversation and explain it to someone, because people will come up to you and say, what did you do during the NPA conference, you know? And they'll ask you, you know, well, do you know how magnets work? You know what gravity is? You know what? They'll ask you these questions, or they'll ask me what the heck the Higgs particle is. And so my goal is to try and see whether I can give you some answer that you can give to those people. Like I said, you don't necessarily have to believe me, but I want you to go from a state of, well, I don't know what charge is, to at least, well, some guy explained it like this, okay? That's my goal. And during my presentation, this is going to be more interactive. You know, I'm going to go and I'm going to stop my presentation. I'm going to ask you, what's wrong with this picture, okay? And I want to know what you think is wrong with what I'm saying, because I love my critics, because it's really the only way I can really improve my theory. If everyone disagreed with me, then I would have nothing to research. It would just be extremely boring. But if someone goes, and this is what often happens, is that, you know, they'll tell me my theory is a big pile of steaming something, and but they will give me some reasons why they think it's bad. And then I will go and research that, and I will in fact find some new things that I need to go look at, and I can incorporate those into my theory, and it either, you know, confirms my theory, or denies my theory, or modifies my theory. But that's how progress is made. So I love my critics, and I want you guys to be critical, okay? So first of all, I'm going to do a little survey here. So who here can raise their hand? Okay, let's see here. Oh, no, you didn't raise your hand. Does that mean you cannot raise your hand? Okay, who cannot raise their hand? Okay. Because otherwise I may actually call on you. Like Greg, I may ask you a question, okay? Two no's make it right. Okay, so my initial talk is on the real God particle. So let's go on to the next slide here. Oh, that's right. I do have it. There we go. Okay, so there's been a lot of hype about the God particle. I think the press has hyped the God particle way out of proportion to what it really is anyways. I mean, but the thing is, according to the standard model, the embarrassment is that all particles should have zero mass. There's no reason that any particle should have any mass. And so they have to invent something so that everything doesn't travel at the speed of light. And so what they invented is really the Higgs field. Now, the Higgs field is actually what's more important than the Higgs particle, okay? The field is just something that the particles go through that slow it down. So my analogy is like a field of corn. So if you're trying to run through a field of corn, it's obviously going to be much more difficult than running through an empty field, right? Now, basically, the Higgs field is supposed to work like that, that the particles, there's something in the field, you run into it, and it's like if you're a really fat person, or you're like a giant tractor trying to go through, it would be more difficult, and that difficulty is a measure of mass. So you can tell your friends, if they want a little explanation of what the Higgs is, that's a kind of a simple explanation for what that is. It's kind of like a cornfield that resists your motion, right? Now the thing is that the Higgs particle doesn't have anything to do with the field per se. I mean, when I was first looking at this, I thought, oh well, the Higgs field must be made of these Higgs particles, and that's what's resisting the motion. But the answer is no. They actually don't know what the Higgs field is going to be made of. What the Higgs particle is that this field is like, I don't know, like an electromagnetic field, and it has waves. And what the Higgs particle is, it's supposed to be the smallest possible frequency that can go through this field. Okay, so very low frequency, like for electromagnetic frequency, I don't know what the lowest frequency would be. It'd have to be like close to zero, right? For lowest possible field frequency. Or like air, certainly there might be a slowest possible frequency below which it wouldn't propagate anymore, right? You can kind of imagine that. Huh? No, I think it's supposed to be the smallest. Well, if you calculate, see, it's the energy of the wave, and the energy of the Higgs boson is found at about 125 giga electron volts, which is like 100 protons. That's a massive, massive particle. If you calculate the frequency of the wave you need to get the equivalent energy, you get a minimum frequency of 2.71 times 10 to the 28 hertz, which is just an absurdly high frequency. You know, I got this information from Matt Strassler's Higgs FAQ, and I dutifully went through and asked him, you know, what the Higgs particle is. He said it's this smallest frequency, and then I went through this math and calculated out what that smallest frequency would be, and that's the smallest frequency. Now, I did ask him whether that was right, and he really didn't answer me, but as near as I could tell, that is the minimum frequency, which seems to be totally absurd.
Means smallest wavelength, highest frequency, inversely related.
So highest frequency is the wave that the Higgs field will support.
Well, I'm not sure about that, but that's the way I understand it. Okay? And the thing is that even with that, we still wouldn't know what the Higgs field is made out of at all. See, so just finding this Higgs particle, the hope is that just proves that there's a Higgs field, and that then they might be able to figure out what the Higgs field is made out of and how it actually interacts with matter, because it's very difficult to understand how matter interacts. They use like a Mexican hat diagram, has to do with spontaneous symmetry breaking, and there's no really way they're going to be able to explain that to any layperson. But they have their reasons. Okay. You have a question?
Not a question, comment. That's the energy, that's frequency of the energy it takes to get that small. So it's not the wavelength is small. That's the energy it takes to break into space at such a small energy point.
I thought that's
the energy of the particle they have to snag to find the Higgs particle.
Well, it is also happens to be the energy, and that's how they get it. They think it's the smallest possible thing that they can get to break out the Higgs particle.
It's like every
But in any case, let me please get on with my presentation here, as my time is limited. So, me personally, I think this whole Higgs boson thing is a complete farce. So, and that what they found at 125 gigabytes, they may have, gig electron volt, they may have found something, but if you look at the experimental data, which is just this exponential curve, and there's this tiny little bump, along with all the other bumps, that is at the 120 gigabyte electron volt, and they say, ta-da, that's the 5 sigma accuracy is the Higgs boson. There's a particle there. It's like, maybe there is, but even if you did find a particle, that doesn't mean that that's the thing that gives mass to the W's and the Z's. You just found a particle. That's just the very, very beginning of verifying this theory. Now, me personally, I think if the Higgs was really out there, that you'd see like this huge spike where that thing is. I mean, there should be so many of those things out there. But, I may be wrong, but I would think that, you get a bigger signal than what's in that. So if I think that the Higgs boson is completely bogus, then what do I think does give mass, and what makes the Higgs field, okay? So I brought myself one prop here, and what this is that it's like two magnets. I painted one red and one black. And I made it so that no matter which way you attach this, it's attractive. So it's kind of like a magnetic monopole. But you can ponder how I made that. But I bring this up because I believe that this is the true Higgs boson, the true God particle. And what is this representing? This is representing nothing more than a positron, which is a positive object, which is the antimatter particle of the electron. So I have black block, that's electron. Red block, this is a positron. Now, what do they do? When they, by nature, intuitively, they attract. And they're what? They're stuck to each other, right? Now, I think that might seem very intuitive to the layperson, but to the physicist, this completely blows their mind. That the idea that a positron and electron could do this, just like for the physicist's mind, they completely deny that this is possible at all. That an electron and a positron could remain in a static, stable arrangement. And why is that? Because physicists believe that all particles are point-like. Well, actually not even point-like, but that they are really literally mathematical points, and that they don't have any surface, they don't have any volume, they don't have anything that can possibly interact. If you had 2 point particles and they came right at each other, they would go right past each other because they have no volume, or there's nothing there. So when they think about a positron and electron coming together, it blows their mind because they can't figure these things ever actually coming together, because you get like Zeno's paradox, that it has to go halfway in space is infinitely divisible, and it would never get there. Or they say that some catastrophe has happened, they would, you know, I don't know what catastrophe they're talking about, but they feel that this is impossible because of this very foundational error that we have a point particle and that these point particles cannot simply just sit on each other. So I want to stop here right now and I want to ask you guys, so who doesn't think that this is possible, that a positron and electron could sit on each other? Who doesn't think that's possible? And you in the yellow shirt, why do you think it's impossible for a positron and electron not to sit on each other?
I've always been, all the reading I've ever done says they would annihilate each other.
And Dowdy, what do you think?
What I think is what's going on. There's something what they call a positronium, like a hydrogen atom.
Well, I want to know why you think this is impossible.
I feel that you can't destroy matter from creating. And both of those particles still exist, but you can't see it. They isolate each other.
So you think they still spin around?
Yeah, this is
Okay.
What you call a virtual photon.
Okay, now to answer the other gentleman's question, I'm going to answer that by a little story. And that once there was a wife and a husband, and every single time, you know, it was Easter, the wife is a terrific cook, and she would go and make this ham. But what the husband didn't understand is that she always cut off the end of the ham and threw it away. And the husband goes, well, why do you do that? Isn't that a waste? And the wife said, well, I learned my cooking from my mom, and she's the greatest cook in the world, and she always did that. Okay. So the husband went and called the mom, and he said, so my wife, she throws away the end of the ham. Why did you do that? And she answers in a similar way. She says, yes, well, my mom, she was the greatest cook in the world, and she always cut off the ham at the end of the ham. So, well, it turns out that, you know, her mother was still alive in the old folks' home. And so finally he went and called her, and he asked, well, why do you cut the end of the ham off? And she said, what? Oh, the pan is too short. Meaning that, you know what? You sit there and you believe things like that. If you don't know the reason why, it may turn out that there is no reason why. And that's exactly what to your point.
That's the common standard theory that they would annihilate.
Yes, they would annihilate. Because this is what happens. This is the standard thing. You got proton, electron together. If they come together, they're supposed to annihilate completely into energy. Okay, so let me give you another possible explanation for that. Okay, now you've got your positron, your electron. They are very attracted to it. The Coulomb forces on these things is fantastic. You can calculate at certain distance, they will attain the speed of light. And when they do, they're going to collide together. Now, you just heard this. You all hear that, right? That's the conversion of the kinetic energy of these blocks into sound. Now, did the blocks disappear? They did not. They just came together. And what's happening is that because this block is heading this way at the speed of light, which is the kinetic energy it contains is 1/2 mv squared, right? So this contains 1/2 mv squared. This block is coming at the other block at the speed of light, which is another 1/2 mv squared. Now, if you add together the amount of energy that's going to have to release when these two collide together in an inelastic collision is 1/2 mv squared plus 1/2 mv squared. So the amount of energy it's going to release is mc squared, where velocity has reached the speed of light. So what we're getting here is not that the positron electron disappear. We think they disappear because they are then lost in a sea of these things. It's like seeing a water molecule, an individual water molecule in a sea of water. You can't see it. And that's why they think it disappears, but it actually doesn't disappear. It becomes this particle. I call this particle the pos electron, okay? And this is the most critical, this is the actual God particle, okay? Not what they found in the LHC, okay? And this makes up the classical ether, okay? And I'm giving it a precise definition of things that we know about. The ether, it's made out of a positron and electron dipole. Two particles that we're very familiar with and we know about it. Because my beef with people who have ether theories, that they've never been able to tell me what the ether is made out of. I'm telling you what the ether is made out of. It's made out of positrons and electrons, these dipole pairs, okay? They completely fill all of the spaces in space, okay? So this is what space is made. So I want to take another survey here, and I want to find out, do you understand that concept of space? Who understands that concept of space that maybe you can explain to someone? Who thinks they can explain
What
that?
concept of space?
Hmm?
Who understands what concept of space?
What space is made out of. Someone asks you, what is space is made out of? Do you think you can answer that question? So a lot of you still can't say, so John, why is it you don't think you can explain to someone else what space is made out of? I'm putting you on the spot, John.
I have to get past the disagreement, but because the wavelength is 10 to the 20th different than my concept. I can answer the question, but you said nobody can answer, and so I got stuck on.
No, I'm just asking you. I just gave you a conception of how space is made of that you could potentially go ask the person on the plane next to you. So if the person on the plane asked you, well, what does some guy think space is made out of? Not necessarily your theory, but I just wondered, did you understand my theory?
I don't. Yeah, you have these cubes, and so you have like the Euclidean matrix of those two cubes.
Are you calling space a thing? Because that's where a lot of us are going to have a problem.
Yes, I'm absolutely causing space a thing.
Space is a place, for me, space is a place for things. It isn't.
Or thing.
It's a no thing.
There's motion, mass, and motion. That's what I believe this exists. I don't believe space is something. So that's you're going to have some disconnect.
So you don't believe that space is a physical something?
Absolutely.
Okay, well that's an interesting point. Who else?
I don't think space is made of these masses, because put something through space, then it will encounter resistance and you won't conserve energy.
Absolutely. That's a great segue into explaining what on earth really is mass. Because now the problem with my cornfield analogy is that the corn would slow you down, right? Eventually it would slow you down, it would stop, it would give you mass, but you wouldn't have inertia, right? It would slow you down, eventually everything would come to a grinding halt, right? So all of our planets would fall out of orbit and be just completely a mess. So you have to explain two things, really. You have to explain what mass is, which I've explained with the corn theory, but you also have to explain inertia, which is once you're going through the cornfield, why do you keep on going through it at the same speed? You don't apparently slow down, even though the corn is in the way, right? Okay, here's the answer. This is why you have to use physical space to do this, because without physical space, you can't give an answer to that question, okay? So all of space is filled with this positive-electron dipole, right? You understand that? And because they are a bit attractive, the positive and negative charges will tend to line up. And it takes energy to push through it. So that's just like the corn. In order to pass through this positive electron space, you have to pull it apart, right? And that takes energy. That's why you always must supply a force in order to move in space. Now the thing is that as these things go apart, and eventually they're going to come and form back in the back end, right? They're going to break open. As soon as the particle passes by, they're going to come together again. Now, once again, these are attractive particles. So when they come together, they will come together with some force. So it's just like if I put like a P in a round magnet, you squeeze it, it's going to force that P forward again. And then that's going to, once again, push the P into the next set of dipoles and pull it apart. And then it's going to slap back together again. That's going to push the P forward. So you get kind of this domino effect where the energy that you initially put into splitting the dipoles is stored in the dipoles and then immediately released back. So that we have this continual storage and release of energy. And this is how inertia works. And this is actually the only explanation for inertia that I've ever heard of. So do you understand that explanation of inertia, why we don't slow down? Because we're going through these dipoles?
One of them, fine, but the problem is you have a whole bunch of them, and so your second law of thermodynamics generates a lot of energy that's not retrieved anymore, so you can't conserve when you go through. You can't keep that.
So you have a friction argument that explained that at this very, very small level of space, that the concept of friction actually doesn't exist because the concept of friction is ultimately things colliding into each other. But in this case, at this level, friction actually doesn't exist and that the transfer of energy is actually perfect. Okay? But I can understand that. But if you want to know more about that, you might want to look at my paper. But I want to get in one other concept, which is that you get the magnetic field as well, okay? So I've explained that these particles can explain both mass and inertia simultaneously, okay? But you can also get what the concept of the magnetic field. I think some people have touched upon that. But you see the magnetic, this dipole particle has the two particles that you need for a magnetic field, which is there's an intensity, because what you can have that these will probably be more or less randomly oriented in space. But if you had these things all aligned in the same direction, that would dictate an intensity. And the other thing that you need for a magnetic field is a direction, a specific direction. Magnetic fields point in a specific vector direction. And if you've got all these things aligned and they're pointing in the same direction, that is a vector determined by the axes between the two charges, okay? So what I would claim a magnetic field is just an alignment of these dipole pairs in space. And how do you get that alignment? Well, this is a little bit sketchy, but I feel that if you have an electron that's moving through space, and then you see all these electron dipoles, they're going to be seeing that charge running through, and like all the positive ends are going to basically be pointing at that electron. And as this goes through, it's going to eventually comb the dipoles such that they'll all be pointing in the same direction. A little bit like if you have a bunch of flagpoles, and you blow wind through it, it combs all of those flags into the same direction. And this is why you need electric current in order to generate the magnetic field, because it is the moving electrons which is combing the field. So how many people believe that a magnetic field is an alignment of these dipoles and that they are aligned because of the action of the electrons? Anyone believe that? Okay, who doesn't believe that? Okay, you, David, why do you not believe that?
Well, I mean, there's a couple things. One is you're talking about a magnetic field, but what's attracting them in the first place? Is that a different type of field? The other comment I would say is that when you're, it's a different comment, but when you talk about space, I get mixed up because you at one time call space where these things are, and then you call it space, it is these things. So I'm just saying when you use that term, try to keep it one or the other. So if you're going to say space that these things are in, then you call that's what space is. But then you say space is this stuff.
Well, this is a strange geometrical argument, and I think that one of our other fellow NPA members that it would be better for me to describe things like geometrical space as being just what you think is this like absolute space, you know, what we move in, and then we have I don't know, like particle space, and that is a space which is composed of all these particles, you know, like you take a bucket and you fill it with sand, that you have the space in the bucket, that's geometrical space, but then you have the space formed by all of the grains of sand, which are giving individual points to that space. And so the individual grains of space are like my ether particle, the positive electron, but the geometrical space still exists within that. That help? But within that, I'm trying to see whether if someone asks you what is the magnetic field, would you give them the answer that it's just an alignment of dipoles within space? Yes.
Please, can I go back to dipoles coming together? They need not necessarily be along the same line. If they come at an angle, they will go around each other.
They may, yes.
And that may create a magnetic field.
That is an alternate explanation, but I'm just trying to say.
We have moving electric charges resulting in a magnetic field.
Yes, Dowdy.
In the what is called a cloud chamber, they have a magnetic field, right? And in this cloud chamber, for example, an electron will electron occurs around the same radius field, but in opposite direction, and they come together.
Well, actually, I'm not interested right now in discussing. What I'm trying to find out is what you don't believe about this particular theory, okay? Well, I would like you to talk about it now because my time is limited. Yes.
Proton, that's an electron and a positron.
Electron and positron.
When I'm coming, they will come together, just like this, and you see it, right? Then it disappears. That positron, that electron and positron are together. Then something happens right here. That's something called a virtual photon. You can't see it. It's a virtual photon. That thing goes for a certain distance, and you don't see any trail at all. You don't see the path. They call it a virtual photon. Then something else happens right here. Then all of a sudden, that electron and positron reappears again. That thing between the disappearance of that trail and that virtual photon, you can't see it, but it's there. What I think is going on, I don't know, I'm going to get your opinion on it. I think there's a positronium, there's an atom. You can't see the thing. The electron and positron, they shield each other off.
Well, I love that you brought that up because while it could be a positronium,
Yes.
I think it's actually the positronium particle. That is actually physical proof that when those positron and electron came together, it didn't annihilate. That what it did, it produced a composite particle. Now, maybe it is positronium. I personally don't think it has to be. But at some point, this particle still has kinetic energy, ran into something, and split back into a positron and electron. That's right. The matter never disappears from the universe. In my model, when you have a positron and electron, they come together. They do not annihilate into just gamma rays. Right. And we are. Okay.
Just wanted you to know you're 3 minutes into the second.
Yes, I know. Okay. Well, let me go and explain just one more thing about the magnetic field. Okay. So I basically explained that all of space, just to summarize, is filled with these electrons, right? And that they can take on a particular orientation, and that if you have electrons coming through the field, they cone the dipoles into the same direction. Now the other question is, well, what actually causes the magnetic field? And if I send an electron through a magnetic field, it deflects, right? Yeah. What causes that deflection? Okay, so you've got these dipoles. They are all pointed in the same direction, right? So you've got all these plus negative arranged here. So if an electron is trying to get through these two things, if the electron will see a positive charge on one side and a negative charge on the other. So what's it going to do? It's going to be attracted to the positive and repelled by the negative, and it's going to go this way. It's going to deflect as it goes through these aligned dipoles, you see? Who gets that? Okay, you get it? Who doesn't get it? You don't get it. Why do you not get it?
Are you telling me that one single positron and electron coming through the air that runs by a wire that's free and willing can align all the mass there in one direction?
Not all of it. You know, it's diverging. That closer to the wire, it's more closely aligned, and then it gets loosely aligned and loosely. This defines the strength of the magnetic field. Eventually, it becomes randomly arranged, and that there is no magnetic field. You get that? Okay. But do you get that when an electron runs through this field, it will deflect because it sees this asymmetric electrostatic force.
In other words, a rock in a pond causes the ripples, the ripple effect that's out, that the wire is where the rock went in, the ripple effect may be 3 ways out, is separated positrons and electrons floating around the water.
Not exactly, but it's wavelength.
That's a fact. The fact is, the magnetic field cannot add energy to the particle.
Yes, it only works on a moving particle. You see, this is why the particle must be moving in order to be deflected, because it has to actually break past these dipoles. If it's just sitting here, it's not going to have any force one way or the other. Okay? Plus, the more particles go by, so velocity is important. This is why Lorentz force law requires velocity. The more velocity you have, the more of these dipoles you're going to be going past each one of these little dipoles is going to be giving an impulse to the particle, and that will determine the net force that's on it. That's why it's velocity dependent. Now, here's one thing I want to give to you guys so that you can go home, and when people ask you this strange question, how do magnets work, okay? How many people right now can give me an explanation that you might be able to tell the person next to you on the plane? Anybody? Anybody? How do magnets work?
You want an answer?
Now, I'm just asking, can you give an explanation to someone on the street how magnets work? Okay, Greg can do it. Anyone else can do it? Okay, who can't do it? Who can't give an explanation for how magnets work?
Are you talking about how they behave or
No.
how magnetism works?
Physically, why do these things come together? Physically, why? I'm not talking about just the. Okay, how many people would be impressed after the next 2 minutes that I could give you an explanation that you could take to someone? But who would be impressed if I could give an explanation that people would understand, right? Who would be impressed, okay? Because in 2 minutes, I'm going to give you an explanation that you can explain to all your friends about why these things come together, okay? Okay, you're in my time here, okay? So I'm going to explain to you how I'm going to give you the, got it.
Please.
I'm trying to give you this explanation, which you can take to your friends. It was really cool because lots of people have this question, okay? You got two magnets. Why do they do this? Why do they attract, okay? Now, the thing I related to is that we know that electrons deflect in a magnetic field, as I explained. I explained like in old CRTs, TVs, we have coils, and we shoot an electron beam, and the beam deflects. And this is how we move the beam across to make the picture in our TV. So we clearly know that electrons can be deflected by a magnetic field. So what's going on in the magnet, okay? And the magnets, they have electrons in it. And basically, they're moving in a spiral, kind of like a solenoid in a wire. And this is exactly why a solenoid wire acts the same as a magnet, because it's got electrons moving in a spiral direction. It's more basically like that, right? So you put the electron that's spiraling in the wire in the presence of this magnetic field being generated by the other magnet. What does it do? It does the same thing as it does in a TV set. It deflects towards the other magnet. And because the electron is stuck inside this magnet, it drags the rest of the magnet with it. So what we're really feeling as far as magnetic forces is all the tiny little electrons trying to deflect this way. They're trying to move that way, but since they can't get out of the magnet, they head toward, they are attracted to the other magnet. So what we're feeling is just the net effect of all these little electrons trying to get at each other. That is what causes the attraction. Okay, so how many people think that was a legitimate explanation? Anybody? Now the thing is that nothing that I just said there contradicts the mainstream, because that's just a simple application of Lorentz force law. It's basically the attraction between two wires with the current going in the same direction, they attract. That's all it is. The only thing I've added to it was that it's the electrons which are doing the attraction, and they're dragging the wire just because they're stuck in the wire. They can't get out of the wire, so the only thing they can do is bring the wires together, right? And that's it. That should have been intuitively obvious to the mainstream a million years ago. As soon as they came up with Lorentz force law, they should have said, oh yeah, well, the reason why magnets attract is because the electrons are trying to get to the other magnet, and that's what you're feeling. Or in the case of repelling magnets, they're trying to get away from each other because they're being deflected the other way. And that's why you feel the repelling force. So it's nothing that's going on between, there's no substance between the magnet that's going on. It's all internal to the magnet, okay? And it's all basically electrostatic force, okay? So what do you guys think? Do you think you can go on the airline and explain that to somebody? Greg, do you think you'll be able to explain that to somebody?
Your explanation?
My explanation.
I wouldn't use your explanation.
I know you would, but
Sorry. Maybe I could.
exactly. Well, the thing is that as far as Nobel Prize, see, this whole thing about whether this can happen, whether positron and electron can come together like this, is foundational. And I think that is a foundational error, as the Earth is at the center of the universe. Because once they defined that Earth is the center of the universe, they mean they had to make all the planets do all these crazy things. But as soon as quantum physics defined these as point particles, no longer could the electron just sit on the proton. That became impossible. Because that's impossible, they can't conceive this particle could not be found in existence, the positive electron. They say that this is impossible. Since this is impossible, you deny what the ether is made out of. And it's such a huge foundational error that, you know, it is as big as the Earth-centered universe misconception, right? Because it's just an assumption. Either you can assume that this is a point particle and, you know, it has no volume, or you can make a presumption, and it is just a presumption, right? It's a postulate that all particles have a fixed finite amount of space, and when they come together, you know, there's some minimum distance which they will approach, and it's not due to any force. It's just an exclusion principle that two particles cannot occupy the same piece of space at the same time. And I think that makes a lot more sense than saying that particles are point particles that they can never actually be touched, and it's completely undefined at all. Completely, what happens if they did? You know, that doesn't make any sense to me. Okay, so I'm going to conclude with the God particle in that, you know, using this thing, I explained a little bit about what is mass, what is inertia, what is magnetism, and I explained it in terms of like Gaudi's experiment there. That proves that there was a particle that existed after the positron and electron came together. That's exactly the evidence I'm looking for. And there are other physical experiments you could do to prove this ether exists. In fact, that's one of my top goals is to get some experimentalists to find this particle. If you can find this particle, that will be the key to the universe, okay? This is the only thing that hasn't been found yet, okay? And it's because they can't see the forest for the trees. This is like the most common thing that you see in particle accelerator experiments, which is this positron-electron spray, because you're busting space apart, right? But they completely ignore all those things, okay? And if that happened, then the Higgs boson and the Higgs field would live up to its hype, which is it would go on to explain what mass is, what inertia is, what magnetism is, what gravity is, all of that stuff, if we did that. And so hopefully by this time next year, I will have done that. Whatever. Okay, I'll just get on to my next presentation. No questions, please. Let's go on to my next presentation. No, not even time for quick questions. Yes. Now, the one thing I didn't explain, though, is how a positron and electron work, right? Did you guys notice that? I didn't. I explained everything in terms of positrons and electrons, but I didn't say how a positron and electron work, right? That's a pretty big hole in the theory. What do you think? That is a pretty giant hole in my theory. I can't explain exactly what a positron and electron is, okay? Okay, well, and I didn't tell you, I mean, I told you how the magnetic force attracts things and how magnets attract, but I didn't tell you how a positron and electron attract, right? I didn't. And if I didn't do that, then I'm really not explaining anything, because I said it's electrostatic force, but then what's electrostatic force? If I didn't explain that, I really didn't explain anything. So, at least that's what I think. So, I'm going to try and explain to you a bit about how charge works. Now, I warn you, I've talked to other people and they said that it's not difficult to understand, but it is so different from anything you have ever heard before that it won't stick, because there's nothing in your current experience that you can latch onto and retain this. So I would advise you to please pay attention to what I'm saying here, because I've explained how charge works probably 3 or 4 times during the weekly science conferences, and people still don't think I have an answer, right? And that tells me that they told me the reason why is because it was so different that it just didn't register in their minds, okay? But this is important about why charges attract. And the way I do it is I do have to kind of resort to giving a physical implementation. If In this case, a physical implementation in, say, a computer, which we all know how a computer works, okay? But I'm saying it is possible, and I wrote this article for the FXQI essay, bit from it or it from bit, which is saying that John Archibald suggested that everything in the world is an elaborate digital computer. So in my article, I literally did that. I implemented the entire world as a plausible digital implementation, okay? So how do you do that? Well, first of all, I define what space is, okay? Now space, I've defined it as physically in the real world as these positive electrons, right? But in the computer, they would be like memory bytes, okay? Every single bit of space is a memory byte. And by definition, space would be absolutely quantized, right? Every bit of space, there'd be some smallest dimension that is represented by that byte, and there's no smaller, okay? There's just that. So how do we define particles within that? Well, those would be like properties. So you put like the number 1 in a byte, and that might be a particle, or a 3, or some other part. You give it properties, right? Now the question is, how do we define an electron and a positron? So, like I said, you give it a number. But in this case, I'm going to say that a positron and electron actually isn't defined by a specific number. It's defined by a specific state. So in binary computers, a bit can hold either 0 or 1, right? So what I'm saying is that an electron is actually something that blinks on off. It's going 1, 0, 1, 0, 1, 0, 1, 0, 1, 0. That's the definition of electron. What's the definition of positron? Exactly the same thing, except opposite phase. Going 0, 1, 0, 1, 0, 1, 0, 1. So if I were to diagram what's going on, if I put a positron and electron next to each other, they'd be going out of phase like this, right? You guys got it? 1, 0, 1, 0, 1, 0, 1, 0, out of phase. Okay? So the question is, I need to get that action to actually create an attractive force. And only attractive between opposites versus 2 electrons have to repel and 2 protons have to repel. I mean, I've heard some other explanations like the proton is like a source of something and the electron is constantly sucking something up, and that makes the protons certainly repel each other. But I think that makes the electrons doubly attractive, right? So that doesn't seem to work. But starting with this out of phase concept, okay, what happens is that if these things generate waves in space, in this computer, that when these waves come together, they'd be like square waves. They're out of phase. When they come together, they add to 0, right? They cancel. So this half wave, this is propagating, it's 0s and 1s. But when they come together, they absolutely cancel. And that creates a region of low pressure compared to outside those particles, which are still going 1, 0, 1, 0, 1, 0. So when these out of phase waves come together, they create a region of low pressure, and that's what causes the particles to come together to be attracted to that low pressure area, okay? You guys get that? And that if you have 2 positrons, they're going in the same phase. And when they come together, they add. So you get a number greater than what's on the outside. And that is a repelling force, okay? So in phase, repelling. Out of phase, attract. Okay, and that's exactly how it would work in this digital implementation. But it can actually also work in the real world I had defined, which is that you have a medium, these things are ringing like bells, and they are ringing at exactly the same frequency, but 180 degrees out of phase. And so when these two are next to each other, the waves between them cancel, causing the attractive force, versus when they're in phase, called repelling. Yes, Greg?
You have only 2 possibilities, either 180 degrees out of phase or 0 out of phase. What about 60 degrees out of phase or 90 degrees out of phase?
Well, this is one reason why I have to resort to the computer implementation, because in the computer, there cannot be any different phases other than 1, 0, 1, 0. There are no other possible phases in a computer.
But they can be 1, 0, 1, 0 at different times. They don't have to be this. They don't have to be this.
In a computer.
They can be this, and then this one comes up, and then.
Oh, no. This is why it has to be in a computer, because in a computer, everything is ruled by the master clock. There's a clock in there, and everything has to move in absolute lockstep in the world.
What is the function of the master clock, and where is it in the concept?
Well, in the computer concept, it's obviously in the computer, and everybody knows where the clock is. It's a chip in the computer, and it is. But now in the real world, getting back to what the real world is, and this is the funny thing, and that is that in order for this to work, there must also be a master God clock that everything in the universe must be ticking by, and actually at the same rate. And that every positron in this desk has to be pulsing at exactly the same rate as the positron in Alpha Centauri. And what's more, the space between them has to be such that there's a fixed amount of space such that it cannot be anything other than a 180-degree interaction, just like the square wave within the computer.
You said you can describe all nature with digital computers. So you can go in the digital world and describe everything.
I'm saying it goes back both ways. You can either think of this as an analogy, or you can think of this as possibly being the way the world really works. That the God really has this gigantic computer. It's got a clock. It's got bytes in it. Because people ask me, well, where's the middle? What happens between the bytes, between the bits of space? And if you think of it as a computer, you go, well, that question doesn't even make sense. I mean, that's like, where's the number 1 when it goes from memory byte 6 to memory byte 7? Did it go through some space? No, it didn't. It's not defined. Right? It can only go from byte 6 to byte 7, right? And it can only do that in a one clock cycle. That's all. Yeah, you got a question?
In the real world computer, how do you deal with time dilation if things have to be out of phase and you're talking about different relativistic frames?
Okay, that's not something I wanted to get into, but I will get into it a little bit. So time dilation is a gross effect on top of this. I believe if you can find the master clock, that clock would be immune to time dilation effects. And that would be the only clock you could find in the world that would do that. But every other clock depends on some particle going from point A to point B. Every other clock depends. So there's some distance it has to travel through. So what you get with time dilation is that if these two blocks are moving through space very rapidly, and all the space is filled with my positive electrons, that will increase the actual number of particles that something has to actually travel through. So instead of, if this was still and had to travel through 10 ether particles to get to the other side, when this is traveling, it might have to travel through 100 ether particles to get to the other side. Because they're going at exactly the same speed, you will have a clock which is running slower because there are just more particles between point A and B. And that's what we see as time dilation. But if you were to measure time according to this God clock, you would see it clicking at the same rate all the time, no matter what speed you were going in. And that's like one possible thing that we can do experimentally to find this thing, right? These are things that you can experimentally find to confirm my theories. And that is, you should be able to find that these positrons and electrons ring at a particular frequency. And that if you look between positrons and electrons, you find out they're 180 degrees out of phase. That's something we can experimentally find. We can also experimentally find this positive electron particle if we know where to look, right? That's another thing that we can find. And we can find this absolutely stable time dilation invariant clock in the universe to show that these things are true. So, what do you guys think of that? Yes?
I'm stuck way back on the first paragraph of your comment, is that space is the electron cosmos. But you're describing a crystalline space. There's no room for anything to move if space is defined as those items.
Yes, it would be. I would give some elasticity due to Coulomb's law, so they're not jammed right up against each other. Because yeah, it was totally crystalline, and you could not make your way through it. So it's more like a gas or a liquid, I would say. That helps.
No, it doesn't.
I think it helps.
You're fudging the meaning of.
Well, you know what? I don't want to get to semantics, and a lot of us like to get into semantics.
But we have to understand you. That's
But
what
I say it's like water, so it's not like a salt crystal. It's like water. Yes, question.
This is a question, kind of a comment. If I understand it Dirac, the physicist came up with the concept of a electron-positron seed.
Well, actually, Dirac just came up with a electron seed. That was the problem, you know. But other people have worked on this problem, you know, like Simone's E. coli. He does a lot of calculations on this, and you know, he found out interesting things. Like if you calculated what the speed of sound from this substance should be, you get the speed of light, and that actually defines what the speed of light is, because this substance is so dense. You know, as the speed of sound increases with density, and this stuff is so dense that you get the speed of light as the propagation frequency. Yes, Greg.
Well, you're first of all, I guess I agree with David, and I don't always agree with David, but I do as far as you do have a tendency to confuse space, the container, the place for stuff, and then the stuff itself. And it
Yeah, I
seems as though
explained that
you
as
are
geometric space
using the
versus
same
particle space.
terms for both. So that's the first thing. Second thing is, I just like to entertain the possibility that what you're calling positrons and electrons, are they actually real things, or are they virtual things that we
They're
sometimes
real
measure?
things.
I'd like to suggest that in some cases they could actually be the things that annihilate and are created are not in fact actual things. That's just at least entertain
Well, only
that
in the sense that they
possibility.
could be in the implementation in a computer. See, this is why I can't explain what electron and positron actually are, but I could resort into this explanation and say that positron and electron are just represented as a byte in God's computer. That's what they are. Right?
The third thing, and this is the most important one, is that if you have a dipole, then it needs to have something, a dipole moment. Presumably, that's something where, in other words, you have to have a distance that's separating their centers, and they have to have a charge. At least the product of those two things should be a number that, I mean, do you have a number for that? I mean, that would be something that you should be looking for.
Well, like I said, other people, the E. coli, they have a precise answer to that. They say exactly how far these guys are about. They say this, like the E. coli guys say that, you know, the density of this stuff is like, you know, millions of times more than steel. They calculate it out.
I know one more thing. I have a problem with when people talk about annihilation and creation. We can't annihilate and create. I'm a believer, so therefore, I don't believe we as people God and the laws of conservation of energy. Say we can't.
Yeah, I would agree. There is no conversion of matter to energy and energy to matter. E equals mc squared is not a conversion of matter to energy. E equals mc squared is merely a reflection of the kinetic energy of two particles that come together. You take two billiard balls and collide them at the speed of light, the energy it releases is mc squared, right?
Are you preaching to me?
No.
I'm agreeing.
Yeah,
That's a relativity.
Okay.
Yeah, here's where I think something goes really circular in your whole argument. First of all, I understand the model, and I congratulate you for getting up here. I think it's great to have you here and to fight for this. You're going to learn something because you're newer. There's going to be some things you can learn here. Absolutely. The thing I see is that this is a problem in general. There's a lot of people that have that same problem here, and that is you are creating an electric field by having things attracting, right?
No.
Well,
The electric
but
field
you're saying
is
that
just
you're saying that the electron and positron are coming together, right? Yes. And these kinds of things you're making as a physical world is going to give us an electric field, right?
No, the electric field strictly is this thing ringing like a bell. It rings at extremely high frequency. That is the electric field, which is dissipating as a 1 over r squared force into space. That's an electric field. I want to make that clear. Electric field is what this resonant frequency is.
What brings those two together? What I'm saying is you've got this all going on, and they come
You see,
together.
okay, who thinks they have the answer to David? What brings those two together with the resonant frequency of the positron and electron? Who thinks they can answer that? Now that I've tried to explain it. Just a hint, it was the interaction of the phases that the opposite phases cancel and they create an attraction. That was my answer.
But there's a constant thing here that I've been always harping on. There's always a conflict, and this is what I'm talking about. In the NPA in general, people talk about everything's based on fields, and this has a field. There is no, and the ether people are trying to give answers to that.
Yeah, but
And
trying to do it
it's a
without explaining what the
mechanism,
ether
it's a
is.
mechanism. What I'm trying to figure out in your model, what's a mechanism and what we call fields in most people's, like Bill Lucas, is a bookkeeping device. He
Not a
doesn't put-
bookkeeping device to me, it's real.
But what I'm trying to say is I'm telling you, I'm confused as to where those two are. Because you're talking about creating with the electron going through, creating a magnetic field, and these things come together. What is the physicality of the thing that makes those together? Because when people call electric fields, those people who know a little bit more about their own theory will say, this is a bookkeeping device. I do not claim to know what that electric field is.
By the way,
So
we're over
Yeah,
time.
we're over.
Oh, yeah.
But I would physically claim that.
Yeah.
Okay. Anybody needing to go to lunch break can go to lunch break.
Yeah.
You don't want to just.
Cool. All right.
Okay, so this is the official end of the discussion.
Yeah.
But you know what? I would love to talk to each and